Greetings to every one of you. So, in this video, we are going to discuss another very important concept from data structures and algorithm, that is linked list. Linked list is a linear data structure that consists of a series of nodes that are connected, in which each node in the list points the next node. So each node contains two parts. So one is the information part and another is the link part. So the information part contains the data and the link part contains the address of the next node. For example, consider this is the start pointer, so which points the first node. Let us consider starting address of the first node is 10 and this is 20 and this is 30 and this is 40. So the start pointer contains the value that is 10, so which points the first node. It contains a data that is A, and the link part of this node contains the address of the next node. So this link contains the value that is 20. So 20 is the address of the second node. So the second node contains the data that is B. Similarly, the second node contains the address of the third node. So it contains the value that is 30. So which points the third node, that is 30. So let us consider we have the data that is C. So similarly, the third node contains the address of the next node. This is 40. So 40 is the last node which contains the data, that is D. And this X represents null pointer. There is no more node available in the list. So which is the last node. So this is the first node and this is the last node. So this is the linear data structure in which we have non-contiguous allocation of the nodes. This is not in the case of arrays. In case of arrays, we need the continuous block of memory in order to store the values. So how to access the nodes available in the list. So traversing, how to perform traversing. So for that let us see an algorithm. So this is the first node. So we consider this is the first node. We set up variable that is the PTR. PTR is a variable. Just we set it to the first node. Okay. So set PTR is equal to the start. So that is what actually we are storing the value of this start in the PTR. Now repeat the steps 3 and 4 while this PTR is not equal to this null. We have to repeat this steps 3 and 4 while the PTR is not equal to null. If it is null, we have to stop the process. Now process the information part of this PTR. So this is PTR. So now we have to process the data that is available in the node. So the information part of the PTR. Fourth step. Now this PTR value is equal to, we have to move the PTR to the next node. So it is link of PTR. PTR is link of PTR. So what actually we are doing, the link of PTR, this is PTR. Now the link of PTR contains what's that? The value that is 20. Okay. So we move to the next location, next node, and we process the particular information. So again we process the information. So again the PTR is moved to the next location. Now the PTR is equal to what's that? 30. That is PTR is replaced by the link of PTR. So now it moves to now PTR is here. Now PTR is here. Similarly, the next time after processing the C, we move the PTR to the next. That is PTR is replaced by the link of PTR. So now every time we are checking the condition, the PTR, whether this PTR is equal to not equal to null. So then only we will repeat this process. So once the PTR here, the PTR value is null, so we stop the process, that is exit. So this is how we can traverse each and every node. Okay, so this is an algorithm in order to that is perform the traversal in linked list. Similarly, how many number of nodes available in a linked list? How to that is find out? So that can also be that is find out with the help of the same type of algorithm. Just we introduce a variable that is called count is equal to 0. In the second step, we are going to that is repeat store the value, that is again PTR is equal to this starting address, the first node. Now we have to perform this repeat the operation, that is the steps 4 and 5, while the same condition, this PTR is not equal to that is null. Okay. Now here the count value, it is incremented by 1, and last statement we have to that is move the PTR value, so that is a link of PTR, and finally that is exit. Okay, so here so initially the PTR is here. We are repeating the process, that is 4 and 5. So just what is the value of this count? Count is equal to initially 0, that is 0 plus that is 1. So now count value is equal to 1. So PTR is the link of PTR. Now PTR is moved. So now the counter value, the count value is equal to 1 plus 1, that is 2. Now the count value is that is 2 already. So again PTR is moved here. Now the count value is equal to that is 2 plus 1, that is 3. Now again counter, the count value, that is the PTR value is moved to the next location, next node. That is here the count value is equal to that is 3 plus 1, that is 4. But now you can check that what's that the PTR value, it is equal, not that is equal to null. So here we stop the process and exit. So now the count is what that 4, that indicates that the given list contain 4 nodes. So this is the algorithm for counting the number of nodes in a given linked list. So in this video we have discussed about what is linked list and how linked list can be represented. We have seen algorithm for traversing nodes in a linked list, and similarly count the number of nodes in a linked list. I hope you understood the concepts. Thank you. Keep watching.